This circuit is the same circuit that we used when we talk about the law of Kirchhoff. Kirchhoff's first law was about the current in a connection point. Current, we talk about current number 1, number 2 and number 3. And Kirchhoff's second law was the voltage that we create in a loop is the same voltage that it has of the voltage drop of the resistors. If you think that Kirchhoff's law is very difficult, I'll give you an alternative. It is the superposition law. Superposition law, we also calculate the current I1, 2 and 3. We just calculate it in 2 times and then add the current at the end. And it is only 2 times because we only have 2 supply systems. If we got, for example, 4 supply systems, we have to calculate all the current 4 times. The law of superposition said that we are going to remove all the voltage supply except one. So for example, we can keep this supply system over here, 12 volts, but we remove this voltage supply system over here, 9 volts. But only the voltage, not the internal resistor. We have to keep the resistance of 1 ohm. When we have done that, we calculate all the current in a system, current 1, 2 and 3. And then we got 3 results. Then we take out this voltage, 12 volts, and then it is only the 9 volts which lead to the current in the system, and we then calculate 3 currents again. And finally we add the 2 current for current number 1, and that is the correct current, and also for number 2 and number 3. We have to decide if current number 1 goes to the right or left up here. We can say it goes actually to the right. We also said that when we use Kirchhoff. Current number 2, we have to go downwards, and current number 3 goes to the left. Again, if we make the wrong guess, and if we guess that the current goes to the right and actually it goes to the left, then the result just get negative. But we said that current number 1 go to the right, current number 2 go downwards, and current number 3 go to the left. I'll just remove all the electrons. Maybe it's easier to see the circuit. And we'll begin using the laws of superposition. First we'll have this one as a supply system, and then we remove this battery but insert a 1 ohm resistor instead. So now we have created a circuit, and then we just have to calculate the current 1, 2 and 3. We have only one supply system, and then we have 2 ohm internal resistor connected in serial with this 5 ohm resistor, and these 2 resistors are connected in serial with this connection over here. This is a parallel connection of one branch is 7 ohm and the other one is a sum of 3 and 1 ohm, since they are connected in serial. So now we have the first situation, the first circuit, and we will calculate all the current. Current number 1 is actually just the supply voltage divided by the total resistance that we just have talked about. So we have R total in the first iteration is, then it is R2 plus R5 for the two resistors over here. They are connected in serial with this parallel connection, so we have to add a parallel connection. 1 divided by and 1 divided by, then it must be R7 for the left branch and R3 plus R1 for the other branch, plus 1 divided by R3 plus R1. We can put in the numbers and get the result. And use a calculator. 2, 5 plus 1 divided by 7 and 3 and 1 have to add together, and 1 divided by 4 is 0.25. We have to add these two numbers, and 1 divided by this number, we got 2.55 ohm for the parallel connection. And totally we got a resistance of 9.55 ohm. We store that in number 1. So now we are able to calculate the current 1 in the first iteration. That is not the correct current, but just the current in the first iteration, and we have to add the current in the second iteration to get the total current. So current number 1 in the first iteration is then the supply voltage divided by the total resistance in the first iteration. So 12, recall number 1 and divide. Then we got a current of 1.257 amp. That is the result for the current number 1 in the first iteration. Now we want to calculate, for example, current number 2, and we can find out the voltage across this 7 ohm resistor, because we just can take the supply voltage minus then the current for number 1 multiplied by these two resistors in serial. Then we got the voltage drop across R7, and if we divide by R7 we got this current. So first of all we'll want to find out the voltage drop across this resistor. UR7. That must be the supply voltage, 12 volts, minus, and then the voltage drop, multiplied by the two resistors in serial, we can put in the numbers and get the result. So 12 volts minus, then a current plus or multiply by 5 plus 2, and subtract this voltage drop, and then we got a voltage of 3.20 volts for the rest. 3.20 volts. Store that in number 3. Then we can calculate the current through in the first iteration. That must be the voltage for R7 divided by R7. Oh, I got right U instead of V all the times because I used, for example, the Danish system. So I just changed that. So, and we can make the calculation. We got 3.20 volts and the resistance of R7 is 7 ohm. And we got a current of 457 milliamp. The current over here is just I1 minus I2. Then we know the current which go this way. But that is the other way that we accepted that I3 will run. We think that it will go the other way. So actually we know right now the current go this way, so the result must be negative. So if we are going to calculate the I3 in the first iteration, it must be I2 in the first iteration minus I1 in the first iteration. So that's where we many times can make a fault when using superposition law. Then we put in the numbers. And we got negative 800 milliamp. Store that in number 4. So now we got the current in the first iteration. We have to do that in a situation where we got the voltage supply over here as the only one, and then we just have a 2 ohm over here. So we have to put in a battery again. Nine volts. We just have to change the internal resistance. 1 ohm. Go. So instead of replacing the battery with a resistor, we just can change the voltage over here to 0 volt. Then we keep the internal resistance, and it is much easier. So we have a resistor of 2 ohm here, but no supply voltage. So it acts as a 2 ohm resistor. Now we just have to make the calculation over here. It's the same way. Supply voltage divided by the total resistance. And of course we got some other values. So our total in the second situation, it is 1 ohm plus 3 ohm plus parallel connection of 7 ohm, and over here 5 plus 2 ohm, and actually that is also 7 ohm, so the parallel connection should be the half of 7 ohm, 3.5 ohm. So R1 plus R3 plus parallel connection. One branch is R7 and the other one is R5 plus R2. Then we put in the numbers. Make a calculation. We can see the resistance for the parallel connection is 3.5 ohm, and totally we get 7.5 ohm. And we have to store that in number 6. Then we can calculate the current I3 in the second situation. That must be the voltage for 9 volts divided by the total resistance in the second situation. Put in the numbers. And we get 1.2 amp. Then we can calculate the current over here, for example I2, and we can use the formula for current divider. So current number 2 in the second situation, that is the total current, that was I3 in the second situation, multiplied by the resistance where the current doesn't flow. That is the resistance over here. So R5 plus R2, and then divided by all the resistance in a parallel connection. We got R5 plus R2 in one branch and R7 in the other. We can put in the numbers. And we have to calculate, was number 7 multiplied by 5 plus 2 and divide by 5 plus 2 plus 7, and 0.6 amp or 600 milliamp. Again, now we have to take care because the current up here is actually current I3 minus I2, but it'll bring the current this way. And we guessed for the start that the current will go the other way, so we have to have a negative number up here. So we have to subtract I2.2 minus I3.2. So I1 in the second situation must be this current minus the other. I3. So I2.2 0.600 minus, and then again 3.2 gives us a negative result. Oh, it was number 7 we got this current. So negative 600 milliamp. And finally, we can calculate the current I1, because that's the sum of I1 in the first situation plus I1 in the second situation. Put in the numbers and have a negative number. And we got 657 milliamp. We can store that in number 10. And the same story for current number 2. I2.1 to I2 in the first iteration, 457 milliamp. And plus second iteration, 600 milliamp. We got 600 milliamp. Cannot find. See, 1, 2, 3. That must be number 4. Oh, we have made a mistake. I don't think that we have stored this result, but it is 3.2 divided by 7. So here we got the current. And we have the 600 milliamp. We add these two results together, 1.057 amp. And finally, current I3. In the first iteration, we got a negative number of 800 milliamp, and second iteration, we have 1.2 amp. So 400 milliamp. Start at number 12, and I2 we can start at number 11. So here 400 milliamp. We can go to the circuit and see if the current is correct. You just have to change the volts over here again so that we got 12 volts. We can see up here the current I3 is 400 milliamp, I2 1.06 amp, 1.06 amp, and I1 should be 0.66 amp. 0.66 amp, yes. So that's the way how to calculate the current in another way using Kirchhoff's law, so that we just use superposition law instead. I use comma as a decimal point. Actually, that's a fault in the English system. You should use a dot instead, but I think you can find out how to make the calculation anyway.